Welcome to the first part of section 3.1, graphing equations of the form y equals mx plus b. So before we dive into doing actual calculations and working with an equation, we probably should figure out what an equation is. So an equation is actually made up of a couple different parts. The first one being it has an equal sign. And hopefully this kind of jumps out because if we think about an equal sign, we actually begin to see the word equal within the word equation. The next thing that we want to think about is that an equation is anchored on either side of the equal sign using expressions. So in one case, we have an expression of y on the left, and then an expression of 2x minus 4 on the right. So please note that an expression can just be a variable. It could also just be a number. We also can refer to numbers as constants because they are not changing. A 5 is always going to be a 5. Or we could have a mix of variables and numbers. And these are going to be held together with operations. So in certain cases, an operation can be an addition or a subtraction sign. Another one might be multiplication or division. In this case, what you're looking at, between the 2 and the x, there's a multiplication happening here. We just don't put the multiplication sign. Oop, I misspelled that. Let's try that again. Multiplication. There we go. Much better. As I was saying, the reason why we don't see the multiplication sign, so if I put in a little x in here, you could imagine how confusing that would be to see the multiplication sign followed by the variable. It can raise some questions. So instead, we opt to use either a dot, or we just choose not to write anything in between them. All right, we're ready to move on to slide 2. So equations have solutions, and solutions come in the form of an ordered pair. So we should probably note that down. Solutions come in the form of an ordered pair. So in general, we should end up getting some sort of ordered pair or coordinate point, so something like this. In the case of this problem, they've given us half of a potential solution. In order for us to figure that out, though, we would need to substitute the 6 into this equation. If we know that x is equal to 6, we can take this 6 and substitute it into the equation. So in this case, we will have y is equal to 2 times 6 minus 4. Now we need to be careful using order of operations. So just as a reminder, hopefully we remember PEMDAS, and that's going to be parentheses, exponents, multiplication, I spelled it right that time, division, addition, and subtraction. Some of you may know this as "Please excuse my dear Aunt Sally." So in this first part, if I have y is equal to 2 times 6 minus 4, I note that multiplication is the first thing that actually really comes into play in this particular equation. So my next line would read y is equal to 2 times 6, which is 12, minus 4. And now I only have one other operation that's left to be done, which is going to be that subtraction. So my final result here is y is equal to 8. So my solution, or my ordered pair for this problem, is going to end up being 6, 8. If I were to check this, so in other words, if I were to start from the very beginning, I would have, and substitute my answer, or my ordered pair here, I would have 8 is equal to 2 times 6 minus 4. Now, what I want you to be aware of is when you are checking, leave this side alone. It's just an 8. We're not going to move anything or remove anything from either of those sides. We're just going to leave that be. And if we start cleaning that up, we're going to have, again, order of operations says to do the multiplication, which is going to give me 12. And then I have 8 is equal to 12 minus 4, which is 8. This gives me a true statement. So as underwhelming as that might be to find the statement 8 is equal to 8, this is what we want to see. So just in case some of you are wondering, well, what is it that I do not want to see? Let's take a look at an example of something that is not a solution for this equation. So let's say that I'm going to move this out of the way just to give myself a little bit more space. Let's say that I give you the ordered pair 3, 4, and I want you to plug it into that same equation that we were working with, 2x minus 4. So again, note that 3 represents the x value, 4 represents the y value. So now I'm going to have 4 is equal to 2 times 3 minus 4. Again, we're going to do order of operations here. 4 is going to be equal to 2 times 3, which will give me 6 minus 4. My next line will be 4 is equal to 6 minus 4, which is 2. We'll take a look at that. This is saying that 4 is the same thing as 2. That is what an equal sign means. Well, 4 and 2 are not the same thing. So this is why we're going to say this is a false statement, and therefore the ordered pair of 3, 4 is not a solution. What I would like you to do now is go ahead and test these ordered pairs to make sure that they are true statements. So I'm going to give you the ordered pair of 1, negative 2, 2, 0, and negative 3, negative 5. Go ahead and pause the video, work these out, and then I'm going to reveal the solutions right when you click play. All right, here are our answers. So as we can see, the coordinate point 1, negative 2 satisfies the equation because we do get a final statement of negative 2 equals negative 2. That's the truth, that negative 2 should be equal to itself. Likewise, when we look at the ordered pair of 2, 0, we also see that this is a solution, or in other words, it satisfies the equation because we get this true statement of 0 is equal to 0. However, the issue does come up when we try to use the ordered pair negative 3, negative 5. It does not satisfy the equation because we get a statement that says negative 5 is the same thing as negative 10. Not true. Therefore, it is a false statement. All right, let's move on to the next video.